Hi there, this is Professor Eckhouse, and I am going to talk today about solving compound inequalities. As you can see from the list of things you're going to learn, there's a couple of things that are in the book that I am not going to cover. If you would like to learn them, you can learn them from the book. There will not be questions on the homework or the test about those topics. All right, so we're going to start with talking about interval notation to describe intersections and unions. So just in general, there are two different words we're going to see when we deal with inequalities, and the word or and the word and. Okay, so it's very, very different. So when we say or, we mean that one or the other could be true and it would make the statement true. So if I said, I will take the red dress or the purple dress, then either one would be okay, right? And it would be true if I got either one. All right, so that is called a union. And so they don't need to overlap. They just need to both exist. Okay, so they can be separate and they will both be true. This will make more sense when we do inequalities. On the right over here, and is just a place where they overlap. So we're saying, where are they both true? Both must be true at the same time. This is called the intersection. Okay, so there's a couple of important words here. Or means union, and means intersection. Okay, so you need to know that those mean the same thing. All right, so another word for intersection, you can think of it as the overlap. The overlap. All right, and when we say union, we are going to use a U that doesn't have a little tail on it. So this is a symbol you'll see in the math homework. All right, so let's start with drawing and then writing in interval notation and describing in words. All right, so we're going to draw this statement right here. X is less than 2 or X is greater than or equal to 3. So what I'm going to be doing in this video is I'm going to do them in different colors. So I'm going to use, let's see, purple for this one, and I will use green for this one. Okay, so X is less than 2, so we're going to have an open circle on the 2, and it is going to go to the left. All right, or X is greater than or equal to 3. All right, greater than or equal to, we're going to put a closed dot, and we're going to do that. All right, so now these don't overlap, but it is okay because it is or. Either one can be true. And the way we're going to show this is we're going to say from negative infinity up to 2, and that is going to be an open and open. And then what the symbol we're going to use to say that these are two together, because remember, or means union. So we're going to say U. Union with, close bracket, 3 to infinity. Okay, so stop, pause the video, and think about that if you need to before we go on. So I don't have a lot of the same kind of problems on here because there was just too many. So if you need to think about it, you should stop, pause, think about it. All right, example 2. So this one is an and that means it is the intersection. Okay, so we're going to do this one in purple and this one in green. All right, so let's start. So what you want to do is you want to have two different places to write, because one is going to be just kind of your work, and then one is going to be your final answer, okay, when there's an and I'll show you what I mean. So X is greater than or equal to negative 5. So negative 5 is here, and we're going to go greater than or equal to is the closed circle. All right, double checking everything. And then less than 4. 4 is over here. And I'm going to draw just above so you can see things clearly. So there's going to be an open circle, and it's going to go less than. All right. All right, so where does and happen? So and happens where they both are true. So stop the video and think about, where are they both true? So they are both true right here, but not at the open circle. So right up to the open circle. All right, so that's why I left us a place to put our final answer. So our final answer is going to go from negative 5 up to 4, and all of these in between. Okay, so that is our final answer. So What we want to do now is we want to say our answer is going to be where they overlap, which is the and. So this again is and, right? Where they overlap. And so we show it right here. All right, so this goes from -5 up to 4. It includes -5. It does not include 4. And if we want to write this in inequality notation instead of interval notation, we would say it as x lies between -5 and 4, like that. All right, so when x is the values in between those two, you want to put the x in the middle. All right, and these symbols always go from left to right, smaller to bigger, smaller to bigger. So they always point in the same direction. All right, next one. So example 3. So try this one and see what you get. Why do I only have one number line? Let's see. All right, so I'm going to draw less than or equal to -1. Less than or equal to -1 is going to be -1, and then to the left. And then greater than 1 is going to be an open circle on 1 and to the right. All right, so the question is and. In other words, where do they overlap? Where do they overlap? Well, they don't overlap. So the solution does not exist. There is no solution because of and, because it is where they intersect. So let's write that. They don't intersect. They don't intersect. They don't overlap, however you want to write it, whatever makes sense to you. All right, so there's no solution to that one. All right, so we're going to look at compound inequalities again with or. So what I just showed you was doing it with just already solved linear inequalities. Now we're going to look at linear inequalities that need to be solved. Okay, so no difference. Once you've got them solved, it's all the same. So we're going to look at an or. So go ahead and try this one. Pause the video and give it a try. All right, so the first one I'm going to do in purple here. So we're going to add 1 to both sides. And I get 3x, the ones cancel out, is less than 9. I'm going to divide by 3. And I get x is less than 3. Now what I always do is I go back and I double check. Did I write my sign right? Did I have to flip it? No, I didn't have to flip it. Double check all those things before you go to draw it. All right, so think about how we're going to draw this one. So we're going to go x is less than 3, so 3 is here, open circle, and it's less than. All right, so now we're going to do the other one. So I'm going to do this one in green. Add 5 to both sides, and I get x is greater than 5. All right, so greater than 5 is open circle, and I go to the right, and the word is or. So when there's an or, this space in between is we can think of it as the union. That's or. Okay, either one is fine. So we're going to say -infinity up to, pause the video and try it if you want to. And then there will be a union symbol. And then there will be a 5 to infinity. Okay. All right, moving on. Give that one a try. This one is an or also. All right, so the first one, we're going to subtract 7. And I get 2y is less than 13 minus 7 is 6. Divide by 2, and I get y is less than 3. All right, less than 3, so I'm going to put an open circle at 3. I'm going to do the other one. So this one will be in green. I'll add 2 to both sides. And I get -3y is less than 12. All right, now I need to divide by, I'm going to put this in pink because I want you to really notice what I'm doing here. Divide by a -3, which means this is going to switch to greater than, because I'm dividing by a negative. All right, so I've got y is greater than 12 divided by -3, -4. Y is greater than -4. All right, so -4 is down here, and I'm going to go to the right. All right, so now this one's a little odd. We haven't seen one like this before. This is an or, okay? So this is not and, this is or. So this means either one can be true. So you want to think, would either one of these be satisfied right here? Yes. Right here? Yes. Right here? Yes. 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 It's either one, right? One or the other must be true. They're both everywhere. I mean, at least one of them, I should say, is everywhere. So the solution is all of it. All of it. So from negative infinity to infinity, or all real numbers. All right, so this is my solution. If you're going to draw your solution, you want to draw this, not this one. This is just the work. So if you're putting your answer in My Open Math, you want to show the solution, which doesn't have any open holes in it. All right, so let's try this one. All right, so start with adding 3 to both sides here, and I get 5. Z is greater than negative 15. Divide by 5, and I get Z is greater than negative 3. All right, greater than negative 3 is going to be negative 3 open circle, greater than goes to the right. All right, and then I have Z is less than, oops, sorry. Just go ahead and work it out. I was just going to tell you the answer. Negative 2 is greater, Z is greater than 16. Divide by negative 2. And I get, this is going to flip, right? So it's going to go that way. And I get Z is less than negative 8. All right, so negative 8 is over here, and I'm going to go less than. So pause the video and figure out how you would write that in interval notation. All right, so I've got negative infinity up to negative 8, and I've got negative 3 up to infinity. Both are open circles, so they have open brackets, and there's going to be a union symbol in between because it's or. So remember, or means this. All right, let's try compound inequalities of the form and. All right, so remember that and means both must be true at the same time. So it's where they overlap. And if they don't overlap, there is no solution. All right, so pause the video and give this one a try. All right, so we're going to subtract 1 from both sides on this first one, and I get negative 4x is less than or equal to 20. Now I'm going to divide by a negative 4. So when I do that, my sign switches, and I get negative 5. Because I divided by a negative 4. So if you don't see how, pause the video and try to figure it out. And so that one's going to be greater than or equal to negative 5. So negative 5 is here, closed circle, greater than means to the right. So many places to mess these up, so be careful. All right, the next one we're going to subtract 2 from both sides, and I get 5x is greater than or equal to 20. Divide by 5, and I get x is greater than or equal to 4. All right, so greater than or equal to 4 goes from here to the right, and I'm very purposefully putting it almost right on top so you can see where is and on this one. Where are they overlapping? Where are they overlapping? And that is going to be here, right here. So we're going to make our answer, and this is what you would put into your answer in the computer, not the work. This is what goes in, and that would be just this part. That's where they overlap. All right, so that's your answer. All right, so how would you write that in interval notation? It goes from 4 to infinity. 4 is included. So it's all the numbers from 4 to infinity. All right, let's try another one. So we're nearing the end here, and not too many left. So go ahead and try this one and see what you think. All right, so you should get 5x is less than or equal to 5. So x is less than or equal to 1. And 4x is greater than, subtract 7 and you get negative 4. I do not switch the sign here. Just because I get a negative doesn't mean I switch the sign. It's only when I divide by a negative or multiply by a negative. I divide by 4 and I get x is greater than negative 1. All right, so I should have done that one in green. All right, so let's do the green one. X is greater than negative 1. So negative 1 is here and it's greater than, so it's open and it goes to the right. And then I've got less than 1. So less than or equal to 1. So I've got 1 is here and I'm going to go to the left. All right, the word is and. So what do you think? And it's going to be this little area right here. So our answer is going to go from negative 1 up to 1, like that. And how do you put that in interval notation? That's going to go from negative 1 to 1 with an open bracket and a closed bracket. If you were going to put this in inequality notation, you would say that x lies between 1 and negative 1. It does not include negative 1, so it looks like that. And it does include 1, so it looks like that. Okay, moving on. So one more problem. Compound inequalities of this form I've been showing you. A is less than x is less than b. Be careful, these always face that direction because you're going from smallest, always from smallest to biggest. Smallest to biggest, left to right. All right, so this is interesting because we've got this compound inequality. So here's what we do. You're going to say minus 3 everywhere in all 3 places. So think about it like this. There's 3 sections, right? The 3 goes away here. Negative 3 minus 3 over on the left is going to be minus 6 is less than, all I have left in the middle is 2x, is less than or equal to 11 minus 3 is what? 8. All right, now we're going to divide everything by the 2 here to get the x alone. So divide by 2, divide by 2. And I get negative 3 is less than x is less than or equal to 4. Look at that. All right, so we would write that again as negative 3 less than x less than or equal to 4. All right, so that's an inequality notation. Now we would put that into onto our number line as going from negative 3, open, and up to 4, closed, and x lies everywhere in between. So all those numbers are possible values for x that would make this equation true. So anything you plugged in, I just want to make sure you understand, anything you plug in to the x value right there would be true. All right, so how would we do this in interval notation? We would say negative 3 up to 4, including 4 but not including 3. All right, so a quick summary of all of these things. So a summary of the situations with and or. So what if you had this, the blue and red right there? What if you had that? What would your answer be if it was and? So your answer would be with and, it would be the overlap where it goes from here to there. Or would be everything. It would be all of it, all real numbers, negative infinity to infinity. And I don't have numbers on here because I just want to keep this simple. Okay, so that is and or for that situation. All right, let's look at this situation where they don't overlap. What is and or? So and is where they overlap, right? So let's make a note of that. It is the overlap. Where's the overlap? There is none, so there is no solution. When they don't overlap and it's and, there's no solution, or D in E. For or, you would just have both of them. It would be the union of the two on the same number line. Okay, so it would be this one here, union with this one here. All right, thank you for watching.